All right, hello physical science students. This is part one of your thermal energy unit. I believe Mr. Flugum comes next, followed by Mr. Olive. But regardless of what physical science class you are in, this is a video for you should you be taking physical science. So, to start off, we're going to do a little bit of review. We're going back to, I think it's Unit 2 of first semester. But we are going to talk about kinetic molecular theory, or KMT. It's not really half as scary as it sounds. Kinetic molecular theory, it sounds all intimidating and such, but it's not. There's only 3 things that you're going to need to know when we're talking about it, and this is what those are. So, what KMT states is that all matter is made of small particles, and we talked about first semester that these are called atoms. So anything that has matter or mass, that is made of atoms. They're the building blocks of our universe. Number 2, these atoms are in constant and random motion. So these atoms don't just like sit still. They're constantly moving and shaking and vibrating and bouncing off of stuff. And they're doing things. And 3, these atoms collide with each other and all sides of their containers. So, kinetic molecular theory. 3 things you got to know. 1, all matter is made of small particles. These particles are called atoms, building blocks of the universe. 2, these atoms are in constant and random motion. They're not just sitting still. They're constantly moving and bouncing off of each other. 3, these atoms collide with each other and all sides of their container. So the 3 states of matter that we're going to talk about here are solids, liquids, and gases. Now in a solid, it's the most rigid of the 3. The molecules are really tightly compact, and they are tightly compact, but that doesn't mean that those molecules aren't moving. They're vibrating and shaking and bouncing off of each other, but they don't have enough energy to actually move past each other. So they're locked in a position. They may be moving and shaking in where they're at, but those molecules don't actually move past one another. Now with a liquid, that's not true. With a liquid, those molecules or those atoms have enough energy that they can slide past one another. And that's what gives liquid its not fixed shaped. It takes whatever shape of the container that you put it in. So, unlike a solid that's really locked in and it's still moving and shaking, but it's not going past one another, the liquid, those molecules, they can slide past one another. And then lastly, we have a gas. These have more energy, and these molecules can actually break free from each other, and they will move at very, very high speeds, and they'll bounce off of each other. They'll bounce off the sides of their container and the walls, and they are typically moving the fastest. And these are the 3 states of matter we're talking about, and those are the 3 parts of kinetic molecular theory. So if you haven't written those down, maybe go back and do that. All right, now into thermal energy. And we're going to start off talking about temperature. So temperature is the average kinetic energy of particles. Now remember, these particles are atoms, and all matter is made of them, and they will be constantly vibrating and shaking. Well, atoms have mass, and if they're moving, that means that they have kinetic energy. So when you measure the temperature of something, really all you're measuring is the average kinetic energy of these particles. Like how quickly are they moving and how much energy do they have? That's all the measurement of temperature is. And we can't really talk about temperature without talking about hot and cold. So when we feel stuff, what we're registering is how much kinetic energy that item has. So when we feel something that's hot, what would be happening is that object, its molecules would be moving very, very quickly, or its atoms would be moving very, very quickly. And when you touch something that's cold, its molecules would be moving less quickly. They would be moving more slowly. So all temperature is It's a measurement of the kinetic energy of particles. If something's hot, its molecules are moving very, very quickly. If something is cold, then its molecules are not moving nearly as quickly. And this is also known as thermal energy. So down here, we've got two containers on the left and on the right. The one on the left would be at a lower temperature. This would be a gas. And these molecules are moving around. They're bouncing off of the inside of their container and off of each other. But as those molecules or those atoms get more energy, they'll be moving faster. And the only thing that has changed is that these molecules are now moving much more quickly than they were over here at the lower temperature. And over here on the right, this would be an example of like a solid. These atoms do not move past one another, but they are constantly shaking and vibrating, and they are more or less rigid. That would give this thing, this object, its solid shape. So heat and thermal energy. So guys, thermal energy will flow from high temperature towards low temperature. And cold doesn't flow. What it is cold is the absence of heat. Cold would be like a reference compared to something else. So cold doesn't flow. Thermal energy will flow. And it flows from whatever the higher temperature item is to the lower temperature item. So down here in our example, we've got a red block and a blue block. We'll say the red block is really, really hot. It has a lot of kinetic energy. It's very high temperature. And the blue block has a very low temperature, which means it has less kinetic energy. Now, as you push these two blocks together, what's going to happen is there's going to be a thermal energy transfer. So the kinetic energy of block A, the really high temperature block, is going to go down. And it's transferring a lot of its energy over towards the blue block, the lower temperature block. And the kinetic energy in that block will go up. That's what this arrow means. It's a transfer of thermal energy. It is moving from the higher temperature towards the lower temperature. And it'll do this until it reaches equilibrium, which means both blocks are the same. So that is the flow of thermal energy. Remember, cold does not flow. I can't take a bucket of cold and dump it on something. When we are heating something up, all we're doing is we are speeding up its molecules. We are making them move faster and faster, giving them more kinetic energy, or thermal, giving that object more thermal energy. So these things, and this thermal energy can be transferred from high temperatures to low temperatures. Cold is just the absence of heat. It's like a point of reference. It's like cold compared to what? All right, lastly, we've got conductors and insulators. Insulators don't allow heat to move through them very easily. Now, in our example down here, we've got a pot of what looks like soup. We're heating it up, and we've got two spoons in it. We've got a metal spoon and a wooden spoon. Now, if you've done this before, you probably could figure out which one of these is the insulator. Remember, an insulator does not allow heat to move through it very easily. Now, if you grab this wooden spoon, the handle is going to stay relatively cool. That's because the heat does not move up the wood very easily because it's an insulator. It is a very poor conductor of heat. Heat won't move through it very easily, therefore we would call it an insulator. Now, conductors are materials that transfer heat really well. Now, the metal spoon is an example of this. If we heat up the metal spoon, the handle is also going to get really, really hot. If you leave it in there long enough and you reach over and you grab it, you'll burn your hand. That's because the metal spoon is an excellent conductor of heat. So, insulators, materials that don't allow heat to move through them very easily. Conductors, materials that transfer heat really, really well. There's benefits to both of them. It just really depends on what you're doing. All right, so that's your first part of your thermal energy unit. I think that's kind of it. There's going to be 2 assignments for you to do. Go back and watch any of this if you need to watch it again. Not a big deal. But just pick one of the assignments to do. There'll be option 1 And option 2, um, just take your time, make sure you do it well, and yeah, thanks guys. Good luck.